So today we're going to be discussing circles. The first thing we're going to talk about is the circumference of a circle. So circumference is the perimeter of a circle, the distance around a circle. So that would be the measurement all the way around here. Now the formula for finding the circumference of a circle is defined by the radius of a circle. So the radius of a circle is the measurement from the center of the circle to any point on that circle. So if we go this way, it's going to be 5 centimeters. If we go this way, it's going to be 5 centimeters. If we draw from the center to any point, it will be 5 centimeters because the center to any of the point on a circle is going to have a fixed distance, in this case, 5 centimeters. So the radius in this case is 5 centimeters. The distance from one end of the circle through the center to the other side is known as the diameter, and that will be equal to twice the radius, in this case 10 centimeters. So the circumference formula is equal to 2 pi r. Also, an alternative formula you could use would be pi d for diameter, because 2 radiuses is a diameter. So the circumference of this circle is equal to 10 pi. This is called in terms of pi. Which is often going to be the way you'll leave your final answer because most questions don't want to work with a decimal. This works with a sort of a variable. Pi is a constant, so technically it's not a variable, but it does give us an exact value for our circumference rather than an approximation. So if we use our calculator and type in 10 pi, we'll get a decimal. I believe it's equal to 31.42 centimeters. Let's take a look. So this is 10 pi centimeters, by the way. Let's just use our calculator really quickly. I may have done this already on my calculator. So if we type in 10 pi, it gives us 31.415, which is 31.42 centimeters. So that is our circumference of the entire arc. It's the measurement of the entire arc around the entire circle. We're going to mostly focus on it in terms of pi. All right? So there are several arcs around this circle, and we are going to be referring to them as minor arcs, major arcs, and semicircles. So a semicircle is the distance from an arc whose endpoints are a diameter. So in this case, C and A. So this semicircle is called CBA. It tells us to go this way. So CBA is our semicircle. It's denoted with 3 letters. If we called it CDA, it would be talking about the other side of the semicircle. We could also refer to this semicircle as ABC, but these all vary. We can refer to one arc in multiple ways. So that is our semicircle. So semicircles are equal to, or half a circle, and its arc measurement is 180 degrees, so equal to 180 degrees. So it refers to the measure of the angle that arc is formed by. So a semicircle is 180 degrees because it's half a circle. All right, I forgot to draw this angle here, but this is meant to be 30 degrees for what we're doing today. Now, a major arc is another arc that is greater than 180 degrees. So if I were to start at point A and travel around the entire circle to point D, this would be called a major arc. That's more than 180 degrees. So that would be an example. In this case, would be we can either call it ABD or ACD. So I'm going to call it arc ABD. So arc ABD, and the measure of that arc is going to be equal to, so if we just calculate up, we have 30 degrees. Oh, we have 180 degrees plus another 50 degrees. So that would be 230 degrees in this case. So that would be 230. A minor arc is an arc that is less than 180 degrees. There are several in this problem. Let's just use AB, for example. So minor arc could be AB and is denoted with 2 letters. So major arcs and semicircles are denoted with 2 letters. The arc measurement of AB is going to be 30 degrees. The arc length, on the other hand, comes from the circumference. So we know the circumference is 10 pi. So to find the arc length, so I'm going to write arc here, will be equal to our arc measurement, which in this case is 180, out of an entire circle, which is 360, times our circumference, which is equal to 10 pi centimeters. So 180 over 360 is really just the same thing as saying it's half the circle, so it's half of 10 pi centimeters. So the arc length of our semicircle will be equal to 5 pi centimeters. Oh, I think I made a miscalculation on that 230. So it'd be 180 plus 90, which would have been 270, excuse me. This should be 270. So that's the arc from A all the way to D. Let's find its arc length. So the arc length will be equal to 270 360ths times 10 pi centimeters. 270 360th is really just 3/4 of the circle. Three times 10 is 30, divided by 4 should be equal to 7.5 pi centimeters. All right, and for our 30-degree angle, the arc will be equal to 30 3/60ths of 10 pi. So the zeros cancel out. This is going to be 1/12 of 10 over pi, or 10/12 pi, or 5/6 pi. I suppose we shouldn't call this 7.5, we should really call it 15 halves. So 15 halves pi centimeters would be the arc measurement for our major arc here. And this was 5/6 pi centimeters for our minor arc of 30, and we had 5 pi for our major arc of 180. Now, arc length and arc measurement are not the same thing. Again, arc measurement is really the angle that corresponds to that arc length, whereas the arc length itself is exactly how much it measures. The angle in the center of the circle we are using to determine the arc length is called the central angle. So the arc measurement is equal to